Okay guys, we are going to start today with a little bit of review of piecewise functions. So, you should have seen piecewise functions in Math 3. What a piecewise function is it literally just uses different pieces of multiple functions, and what function to use when is based on the intervals. So the intervals are always going to be located after the commas. So like this right here shows the intervals. So for the interval x is less than 2, use the first equation. And when x is greater than or equal to 2, you use the second equation. So there's going to be a couple of different things that we're going to do with piecewise functions, but the first thing that we're going to do is just going to be to evaluate some. So if we're using this function for f of x and we want to evaluate the numbers down here, then for any numbers that are less than 2, we're going to plug that number into x for the first equation. If the number is greater than 2, or if it's 2 itself, since it has that equal to bar in that second equation, then you're going to use the second equation. So for f of 0, that means x equals 0. Then 0 is less than 2, so you're going to use equation 1. So you're going to do 2 times x is 0 plus 1. And then whenever you're solving that out, 2 times 0 is going to be 0 plus 1. And then that's just going to equal 1. And sorry if my handwriting isn't great. I don't have the best pens to use on this laptop, but we're going to try. So then next we're going to do f of 4. So that means x equals 4. And since 4 is greater than 2, you're going to use the second equation. And the second equation is x squared. So we're just going to plug that 4 in for x, and you'll have 4 squared. And 4 squared is just going to equal 16. And then you're done with f of 4. And last one we're going to evaluate is going to be f of 2. So that means you're going to plug 2 in for x. Since that second equation has that little equal to line right there, that means we're going to use that because that's the equation that we use whenever you have a 2. So if your number is the number where it breaks between the two intervals, just look for the interval with the equal to line in it. So we're going to use the second equation, which is x squared. So you're just going to do 2 squared, and 2 squared is 4. So that's how you evaluate these. So that shouldn't be too bad. And then we're going to go on to graphing a little bit. So with graphing, there's a few different ways that you can do it. The way that I want to show you, like by hand, is going to be making a table of values and then plotting the points. So we're going to have some different x values, and then we're going to have values for f of x. So the main number that you obviously need in here is going to be where x equals 2. So I'm going to try to do a few different numbers around there, and we're going to try to plot some of those. So I'm just going to start with 0 because that's a little bit away from 2. I'm going to go to 1, 2, 3, and 4. So we've got a few different numbers around that x equals 2. So where x equals 2, we know that our graph is going to break at that point. So what I'm going to do is I'm going to draw a line right there where x equals 2. So that means that on this side of the graph, you're going to be using 2x plus 1 as your equation. And then on the other side of the graph, so over here, I'm going to try to change my color. Over here, you're using the other equation, the x squared. Okay, that didn't work. But you guys see what I mean? You know that that's where the graph is going to break. So let me get rid of that so that we can go ahead and get these graphed. So I'm going to use my red pen. All right, so first I'm going to start by just filling in this table of values. So for f of 0, that means you're plugging in a 0 for x. You're going to be using that first equation, so 2 times 0 plus 1. We did that on the last one. It turns out to be 1. For the 1, that's still less than 2, so you're still using the first equation. So it would be 2 times 1 plus 1. 2 times 1 is going to be 2, plus 1 is going to be 3. And then whenever you get to the 2, whenever you're graphing it, you're going to want everything up to that 2 in the first side of the graph. So you're not going to want to stop where x equals 1. So I'm just going to come over here and make a note to myself so that I know to use it. I'm still going to need the f of 2 using the first equation. So I still need to know what that number is. So that's going to be 2 times 2 plus 1. So that would be 4 plus 1. It's going to equal 5. And so that's not where the actual value is at f of 2, but I still need to know where to go in between x equals 1 and x equals 2. So I still want to make a note of that to myself so that I know where the graph is going in that spot. So then I'm going to find the actual value of f of 2. And so that would just be 2 squared. And that's going to equal 4. And then f of 3, you're still using that second equation. So it would be 3 squared. That equals 9. And 4 squared equals 16. So then you're going to want to start graphing these points. So for each of these now, you have an x here. And then you have your y's, your f of x, that's the same as a y coordinate, in that 1, 3, 4, 9, 16. So that's going to give you the points. So like right now we have the point, oh, sorry, I forgot to change back. So right now we have the points 0, 1, 1, 3, 2, 4, and so on. You guys can kind of see like what I mean by using the x and the y. So we're going to start with the point 0, 1. So 0, 1 is going to be right here. And then it goes to 1, 3, which is right here. And then the spot that we would put the graph if that equation went to 2 would be at 2, 5. So instead of putting a point there, what I'm going to do is put an open circle. So if you guys remember, an open circle means that it goes up to that point, but there's not an actual value at that point. So then, because we've got these, you can kind of see a line is forming, and so you can go ahead and draw that line. If you wanted to fill in the table for these negative values so that you could go ahead and get the points, you could do that if you wanted to. But if you don't want to, you can just go ahead and draw that line once you get to that point. So then I'm going to start filling in the other side. So I would have 2, 4 was where one of my points was. So that's right here. And then it was 3, 9. So 4, 5, 6, 7, 8. 9 is going to be somewhere up here. 16 is like way off of our graph. X squared, it's going to be a parabola. You guys know what it looks like. Just kind of make this a little bit curvy. And then put an arrow to indicate that it's going up right there. So that's kind of what the graph of that would look like. You can also use a calculator to graph these. It's just a little bit tricky, but you can use the TI-84s to do that. And then I'll have to show that to you guys later. And then you can also just use Desmos.com. That would be my recommendation because Desmos is allowed on like NCFEs and EOCs now. So it's a really good tool to use, and you can do that on the Desmos app on your phone, or you can just go to Desmos.com on the computer. So I'm sure you guys have used it before, but I'll just write it up here, Desmos, in case you want to use that. And I'm planning to show you guys how to do it on Desmos in class if you want to see that. And then that's really all that I need to go over right now for piecewise functions. Just I need you to know how to evaluate them by plugging the numbers into the equations like we did here, and then how to graph them. So I hope this is helpful.